All right, this lesson is on projectile motion. A projectile is an object that rises and falls under the influence of gravity. A projectile motion is the height of an object that has a function of time. Projectile motion can be modeled by a quadratic function. Any object that is thrown upward or launched into the air, such as a baseball, a basketball, or a soccer ball, is a projectile. We do have a quadratic function here where the -16 represents the constant due to Earth's gravity. The v0 represents the initial vertical velocity at time of 0. And then the green number, h0, represents the initial height of time of 0. This model has some limitations, so we won't take those into account, such as the air resistance, the wind, or other real-world factors. So in our word problems, we're going to ask you to find some important pieces, such as the time when it reaches the highest point. So when we're asking you for the time when it reaches the highest point, we're asking you to find the x-coordinate of the vertex. So we're going to use the equation for the axis of symmetry of x equals negative b over 2a. If we're asking you to find the highest point, we're asking you to find the max of it. So we would say we would take the y-coordinate. So what you do is you substitute the axis of symmetry value into the equation to find y. If we're asking you to find the time when it hits the ground, then we're asking you to find the x-intercepts. So then we would set the equation equal to 0 and solve for x. The last thing we might ask you to do is to find the height at any point in time. So what that means is you're substituting x into the equation. So you're substituting the time in seconds to find the height. So here's an example. We have a soccer ball that is kicked from the ground into the air with an initial velocity of 32 feet per second. And we want to use the equation for an object that has been launched into the air. So our starting point is going to be the ground. So our height is going to be 0. And then we have our initial velocity of 32 feet per second. So our v0 will be 32 feet per second. So when we write our equation, this will be the equation that we're going to use. We're going to go ahead and substitute in h of t and then -16t squared. The v0 will be 32t, and then the h will be 0. So then we would substitute those two numbers in, and then you can drop that 0. So h of t will be -16t squared plus 32t. And that is our function. It asks us to identify what is h of t. So h of t represents the height of the ball at any time. It's the height of the ball in feet at any time. The t represents the time the ball is in the air at any point, and that's in seconds. Part B says, what is the ordered pair for the vertex? So when we find the vertex, we have been doing that already in class by using the axis of symmetry equation, x equals negative b over 2a. So this is our a, and that is our b in the equation. So we'll go ahead and substitute that in. So the b is 32, and then our a is negative 16. Now we simplify that. We get negative 32 divided by negative 32, which is positive 1. So our x coordinate is 1. To find our y coordinate, we substitute 1 into the equation, into the function for t. So negative 16 and then 1 squared plus 32 times 1. And then we simplify that. We get negative 16 times 1 plus 32 times 1. Negative 16 times 1 is negative 16. 32 times 1 is 32. And we get 16. So the ordered pair for the vertex is 1, 16. So then it's asking us for what does the vertex represent in this word problem? What this represents is the maximum so now let me write here. It's the max height of the soccer ball. So this is the height right here, and then this is the time at that max height. So the max height of the soccer ball is 16 feet after 1 second in the air. Then it says, after how many seconds will it hit the ground? So imagine here is our coordinate plane. This is our time, and this is our height. It's going up, and then it's coming back down. It's going to touch at some point over here. After how many seconds will it hit the ground? So here's the ground. How long does it take? So we're looking for the x-intercept. After how many seconds will it hit the ground? So we have our height here of 0. So we have some number x and then 0. So what we do is we set the equation h of t equal to 0 and we solve it. So we say 0 equals negative 16t squared plus 32t. We've done some solving of quadratic equations by completing the square, factoring, and undoing, and that's what we're going to do right now is we're going to try and factor this, and we can factor this by greatest common factor. We can take out the GCF. We can take out a negative 16. We can also take out a t. So we're going to divide that out. And now what we're left with is a t minus 2. So this is our GCF is the negative 16t, and then what's left is 2, or t minus 2. Now we're going to use our zero product property. We're going to set each factor equal to 0. So negative 16t equals 0, and then t minus 2. And then we solve those for x, or in this case t. So I divide both sides by negative 16, and I get 0. So this represents right here 0, 0. The second one, we add 2, we add 2, and we get t equals 2. So that's this ordered pair over here, 2, 0. So one x-intercept is 0, 0, and the other one was 2, 0. So it says, after how many seconds will the ball hit the ground? So it starts at 0, 0. It goes up in the air, and then it comes back down after 2 seconds. So 2 seconds later, it'll hit the ground. Now it's going to ask us here in a moment to graph the entire function. And I'm already starting to graph it in part F, graph the function with all the important pieces. And I did a sketch here. So we actually have in part B and C the vertex. So I'm just going to go ahead and label that this ordered pair here over 1 up 16, because that was the vertex. That was the maximum. So after 1 second, so at time of 1, we were up here at 16 seconds. All right. The next part says the point 0.52 is a point on the graph. What does this represent? So since I've already been sketching that graph. So after 0.5, so here's 0.5, we are up at 2. So 0.5, comma 2, what does that mean? That's saying is after a half of a second, the ball will be 2 feet in the air. So this is the x, and that's the y. So after a half a second, the ball will be 2 feet in the air. All right, now again, I did graph on the previous steps all the important pieces, and then I just took a snapshot from a graphing calculator what it looks like also. So again, the x-axis represents the time, and the y-axis represented the height. And the height was in feet, and the time was in seconds. This is the vertex, the max. That was that x-intercept and x-intercept.